If you cannot see the screen, say no. Yes, okay, very good. All right. So today is our first official lesson of the second semester. All right, this is lesson 1 of Unit 5. Today is about systems of equations. All right, so Unit 5 is about systems of equations. All right, so this is our schedule today. First, we're going to review the homework policy again, some more details. Then we're going to do some warm-up problems. We always start with some problems, but since last class we did not have any homework, we're just going to start with some pre-assessment problems. All right, and then we have some new material about how to solve systems with substitution, and then of course we have practice problems. All right, any questions about the schedule? All right, so let's start with a little bit more details about homework for new students. All right, so we do have some new students. All right, we do have some new students for the second semester. So remember, when you're doing the homework, you have to complete it as soon as possible. Remember, the due date is next Friday. All right, always show your work. All right, so if you don't show your work, I can't grade it. And then complete your homework in a notebook or on paper because it's just easier to do your work there. I don't recommend doing it on Google Docs or something like that. Also, after you're done, scan or take pictures of your homework and submit it on Google Classroom. Okay, so let's begin with some warm-up problems. All right, these are from the pre-assessment, and I'll encourage more participation. Right, you can unmute yourselves and tell us how you solve it. So I'll give you some time, and then we'll walk through it together. Wow. All right, let's go over this. This is very easy, just order of operations. All right, who wants to volunteer? All right, William is raising his hand. Okay, very good. William, could you show us how to do this?
Okay, so the first step is to simplify. Well, we just need to simplify the equation. So we first do 2 plus 4 times the absolute value. Well, we first change the equation to 2 plus the 4 times the absolute value of 7 plus 4 over 8 plus 15, which is equal to 2 plus 44 over 33 over 23, which is 46 over 23, which is 2.
All right, so this is 46 over 23, which is equal to 2. All right, very good. Hopefully everybody got 22. Wait, no, not 22, just 2. Hopefully everybody got the correct answer. That was pretty easy. All right, let's do this next one. Practice some combining like terms and simplifying. All right. All right, let's see how we solve this. Okay. All right, let's find somebody else this time. Let's see, we have answers. Okay, how about Kaylee? Kaylee, can you show us how to solve this?
Sure. So you turn it into, so you get rid of the parentheses by multiplying the insides by the outsides. So that the first parentheses becomes 4x plus 8, and then you subtract the second parentheses, which is 3x plus 9 plus 9. And then you add 5 at the end.
All right, and then you combine like terms.
Yeah, and then it becomes 3x subtract 3y plus 22. Plus 22, sorry.
All right, very good. Do you remember what this property is called when you get rid of the parentheses?
The distributive property.
Very good. All right, distributive property. Make sure you know that. All right, number 3. All right. Do you have any answers? So x is equal to -5 to 7 interval notation. Very good. All right. So let's see if that is correct. So, William, do you want to volunteer to again to show us how to do this?
Sure. So we first have to multiply 2 on all three sides, which will turn the equation into 12 is greater than 3x minus 9, which is greater than -24. Then we have to add 9 on all sides, which would change the equation to 21 is greater than 3x, which is greater than -15. And then we divide 3 on all three sides, which makes 7 is greater than x, which is greater than -5. And if we write that in interval notation, it'll be x equals to negative, x is any number from -5 to 7, excluding -5 and 7.
All right. Very good explanation. Now we can graph it. All right. So just draw a simple number line. So this is -5. This is, let's say, 7. All right. This is, just exclude both of these. All right, with open circles. So next problem. All right, let's do this problem. So x-intercept and y-intercept, pretty simple. So who can handle this time?
I did.
Oh,
I haven't resolved it yet, but I know how to.
what was that? Who is speaking?
I haven't resolved it yet, but I know how to do it.
You haven't solved it yet?
Yeah, but I know how to do it.
Oh, all right. Sure. You're who?
Find the x-intercept and you just get x equals 0, I think. No, wait, no, wait. What?
Are you finding the x-intercept right now?
Yeah.
So what do you do?
No, sorry. You make y equals 0,
All right.
and then x y equals 0. So x equals to -6 equals to 5/3 x plus 35/3. And then we combine like terms. 5/3 is 35/3 is 40/3 x. No, that's right. No, wait, sorry, I'm wrong. You minus 35/3. And on both sides, you get -18 equals to 5 plus 5x. And then you minus 35. I don't, negative 53. X equals to negative 53. Then y. You get x equals 0. Wait, can you hear me?
What?
Can you still hear me?
Yeah, I can still hear you.
Oh, okay. And then you equals to 5/3 times 0, so no, because 3y minus 6 equals to 5/3 times 7, so 3y minus 6 equals to 35/3. And then you plus 6. You add 6, I mean. So you get 53/3.
How about let's multiply everything by 3 first?
Okay, so they cancel out. 3y equals to 35 plus 18, and then you divide both sides by 9, and you get 53 y equals to 53 ninths. And then you found y, x, and x intercepts.
All right. Good. So William, do you agree with that?
Yes.
Okay, good. So let's move on. We're going to run out of time. So for the warm-up questions, last one, I'll just walk you through this. So graph this is in slope-intercept form, right? So this is our y-intercept, -3. Right here, our slope, 1/4. We're gonna go up by 4 and then go to the right by 4. It's gonna look like this. the smaller the slope, the less steep it's going to be, right? So if it was 4, it'd be quite steep. But since it's 1/4, it's not going to be that steep. All right, so this should be correct. Okay. So now let's look at systems of equations. The definition of a system of equation is a set of simultaneous equations with common solutions that fulfill all of the equations. All right.
Yep, I get it.
What was that?
Nothing.
Okay. So we can have an example of systems of equations. So right now we're going to be working with
Wait, aren't there 3 methods to solve them?
3 methods.
Well, I think.
There's actually more than 3 methods.
True, but like there's 3 principal methods. Or something like that.
In Algebra 1, there's 3 methods. There are different methods to solve.
Yeah.
Definitely, there are at least 3 methods. I'm going to teach you all 3.
Okay.
Alright.
Yeah. All right.
You know more than 3 methods. Definitely. You can also solve systems with matrices.
Oh yeah, those things.
Yeah, and though that is a bit more advanced, you learn that in linear algebra, which is a college course. So I won't be teaching you that. But definitely we'll have the 3 basic methods, all right?
Yeah.
Okay, so Hugo, could you give us an example of systems of equations?
Okay. Y equals to 35. No. Yeah. Y plus X equals to 35. 0.25 X plus 0.25 Y equals to 4.9. And then you solve it.
All right, that is definitely a systems of equations. So now that you guys know what it looks like, all right, it's just 2 linear equations together, right? And you want to find an X and a Y. X and a Y that satisfies both equations. All right, you have to find one that satisfies both equations, right? You can just find a set that satisfies one, all right? For example, for this first equation here, let's say y is equal to 10 and x is equal to 25, all right? That satisfies the first equation, but it probably does not satisfy the second equation. So you're going to have to find a solution that satisfies both equations, and then we're going to have to definitely learn how we're going to do that, right? So that is what I'm going to teach you today. So let's look at what actually is a system. All right, so a system is actually, since you can interpret it with a graph, that is one of the methods to solve it. I do not recommend it. But this is a graph of a system. As you can see, you can graph these. These can be graphed, right? And the solution to the system is basically the intersection of the 2 graphs. Right? The intersection is the solution of the two graphs, right? Okay, so in this example we have x plus 2y is equal to 6, right? And then we have, let's say, y equal to x. Okay, and if you graph these, you can see that the intersection point is going to be at 2, 2. If you plug 2 and 2 into these equations, you can see that x equal to 2, y equal to 2, right? And then if you plug them in and see that they do work, all right? The equations do hold true. So this is how we're going to denote. This is how we're going to denote our answers, right? This is how we're going to denote our answers, right? So note going to denote answers in coordinate in like this format, right? Because in reality, the solutions are just intersections of the two lines, and it's just a point, right? So we're going to denote it in point format. Okay, so let's use that same example, and now we're going to solve it with substitution. See, the problem with the graphing is that it's very inefficient. Let's say we had a system like this, all right? You find this point. How are you going to do that? No way. It's going to be very hard, especially when it's a decimal. All right, so let's not use graphing. Graphing is a very bad method. It's very important to know that graphing can help you find a system. It shows you that the intersection is a solution. Right? It helps you understand what a system is, but graphing is not an actual method to try and solve systems. Now let's solve with substitution. Okay, the two main methods, all right, the third method is graphing, but the two main methods that we're going to learn in this class are substitution and elimination. So with substitution, basically what we do is we find the value of one variable. Okay, so right now we already know the value of one variable. All right, we know what y equals. It's like solving a literal equation. Right, we find the value of y. Y is equal to x. Does anybody know what we can do with that?
Yeah, you put for every y you put an x. So x plus 2x equals to 6. And then you solve for x and then you get y.
Very good. All right, so does everybody agree with that? Very good, right? Okay. So let's look at this. Since we know that y is equal to x, we can just substitute x for every y. All right, let's look at this. X plus 2x is going to be equal to 6. Because we already know that y is going to be equal to x. 3x is going to be equal to 6. X is equal to 2, which is equal to y. All right, so therefore we know that the solution is 2, 2. Okay? So, are there any questions? Any questions? Does anybody have any questions? No? Okay. All right. Let's keep going. So here are some practice problems we can do. All right, remember, first pick a variable to isolate on one side. For example, I can help you with this a little bit. All right, I'll give you a hint on this one. All right, so please start doing this. For those who don't, I'm gonna help you. Let's do it with the second equation. So let's try to find the value of x. All right, so x is gonna be equal to negative 8y plus 26. And then for every x you see in the first equation, just substitute negative 8y plus 26 in it. And then you can find the value of y, and then the value of x, right? So let's try that. Everybody try that. All right, let's see. All right, so Grace said 2, 3. Kaylee agrees. Then Ethan also agrees. Very good. All right, let's look at this. So we know that x is going to be equal to negative 8y plus 26. We can substitute that in. All right, so 5 times negative 8y plus 26 plus 2y is equal to 16. We can solve this real quick. Plus 130 plus 2y is going to be equal to 16. All right, now we have negative 38y. is going to be equal to negative 114. All right, and then we get y is going to be equal to, I don't know. What is this? Oh, it's 3. Y is going to be equal to 3. And that's quite easy from now on. So what you need to do is you need to sub in 3 for y here. So 5x plus 2 times 3 is going to be equal to 16. 5x is going to be equal to 10. X is going to be equal to 2. You get 2, 3 as your final answer. All right. Number 2. All right. Let's see. You have answers. 1, 5. Very good. So let's see if that's correct. So Grace, you answered very fast. Good job. Would you mind volunteering to explain your answer? You can unmute yourself.
So I focused on the last equation, and then I applied the -1 from Q to the other side. So I flipped the sign. So -2p plus 7 equals to Q. And then I applied to the first equation 8p plus 7 times, in parentheses, -2p plus 7 which is equal to 43. And then I multiply what's inside of parentheses outside, and I got negative 14p plus 49 plus 8p is equal to 43. And I combined the two like terms, 8p minus 14p, which is equal to negative 6p. And then moved the 49 to the other side and got negative 6. And so p is equal to 1. And then I applied the p back into the second equation. And then I got 2 minus 7 equals to negative q, which is equal to negative 5 equals to negative q, which is 5 is equal to q.
Very nice. All right, so we can say that it's 1, 5. Usually the letter that comes first is, we can denote as the first, coordinate here. So 1, 5. Good. Great. All right, so let's move on. Number 3. All right, let's see. We have 2 comments again. Okay, 2 answers. All right, Ethan, very good. -2 and -2. Could you explain your answer?
So first okay, thank you. First you move b to the other side. So -5a equals -b plus 8. And then you
Wait, hold on.
okay. And then you
Wrong one.
times -1 on both sides. to get that. So then you substitute b for 5a plus 8.
Okay, so we get 9 times 8 plus 5a equal to negative 32, right?
And then you simplify and you get 52a is equal to negative 104. And that means that a is equal to negative 2.
All right, very good. So after we get a, right, we can substitute that in for the first equation. We get 10 plus b is going to be equal to 8, right? And then b is going to be equal to negative 2 also. Very good. So we get negative 2, negative 2. Good job. All right, next one. All right, so let's do this one. Okay, I'll walk you through this one. So this one, right, let's choose a variable. How about let's choose m, all right, let's choose m. So you get 2m is going to be equal to negative 6n minus 5. All right, divide by 2, right? That's not a good choice. Let's not do that. You get a fraction. How about let's use n, but then we also get a fraction. Well, either way we get a fraction. So let's just do 2m is going to be equal to negative 6n minus 5. All right, so then m is going to be equal to negative 3n minus 5 over 2. Okay, so 4 times negative 3n minus 5